Holy hot dog, you guys. We are down to the final section of this unit, which is on transformations with polynomials. Which, guess what, you guys? The same transformations that we've done in the previous units work the same exact way. So, this is going to be kind of a review of the previous units when we dealt with transformations, but this one has something that's slightly different. We are going to be dealing with polynomial transformations using function notation, which, first of all, you guys, it's going to be fun because fun is in the word function. But secondly, do you guys see up here how we have this f of x thing? Whenever we have f of x, that is function notation. So we're going to be using transformations with the function notation, but they still work the same way, and they still kind of fall in the same spots, the A, the B, the H, and the K. And the A, B, H, and K, you guys do the same exact things as they did before. So, the A value, so think back to when we did logarithms, absolute value. Okay, think about what the A value did, because guess what? It does the same thing. Okay, so when our A value is less than 0, which numbers less than 0 are negative, it will reflect over the x-axis. Okay, remember you guys, the A value does everything vertical. So when you reflect over the x-axis, you're moving in a vertical motion to cross the x-axis. Okay, when A is greater than 1 or less than -1, or basically, guys, when A is not a fraction, the graph becomes more narrow, and this is called a vertical stretch. So I have a little picture here to kind of demonstrate what that is. Okay, so if the blue graph is our parent function, or the original graph, if we stretch up, I kind of visualize stretching up the arrows upward. Okay, if we do that, the graph is going to get skinnier. So remember, no matter what, if the number is not a fraction, it gets skinnier, which in this case will be a vertical stretch. Okay, now, when it is in between -1 and 1, so when A is a fraction, essentially, it will get wider, and this is called a vertical compression. So again, I have a little picture to demonstrate, because this is probably the hardest one to get. So if we start at the yellow graph, so our dashed line, if that's our parent, and we get to the blue graph, so this time, envision that you're pushing your arrows downward. Okay, if you push your arrows downward, it will make the graph get wider. Okay, and this is called a vertical compression. Okay, so no matter what, if your A value is a fraction, it gets wider. Okay, and if it's not a fraction, it gets skinnier, which is a vertical stretch, and when it gets wider, is a vertical compression. Okay, so the A value deals with everything that's vertical. Vertically reflects, vertical stretch, and vertical compression. The B value is the opposite. So first of all, the B value is the number inside of your parenthesis. First of all, it must be in a parenthesis. Second of all, it is multiplying to your X value. Okay, be careful. The H is also in a parenthesis, but it's added or subtracted to the X. So be careful. And I think I forgot to mention, you guys, the A value is in front of your F. Okay, see, it's A then F. So if you see a number in front of the F, that is the A value. But anyways, the B value is the complete opposite of the A value. Okay, it does everything in the reverse. So when the B value is negative, it now will be reflecting over the y-axis. Okay, so again, remember the B value, think everything horizontal. It reflects in a horizontal manner. Okay, same as with the A value, when your B value is not a fraction, it gets skinnier. So if you see here, the A got skinnier and the B got skinnier, but they're called different things. Okay, when the A got skinnier, it was a vertical stretch. When the B got skinnier, it's a horizontal compression. Do you see how the arrows are moving in from the yellow to the blue graph? So if I zoom in here, we are compressing horizontally the yellow graph to become the blue graph. So it's getting skinnier, but in a different way than the other graph when we had a vertical stretch with the A value. Guys, so again, I kind of like to visualize what's going on to know what kind of, what's going on, if it's a stretch or a compression. Okay, but if you cannot visualize it, just remember that these are the exact opposite of the A. So when A is not a fraction, it's a stretch. When B is a fraction, mixing up. When A and B are not a fraction, when the A is not a fraction, it's a stretch, but when the B is not a fraction, it's a compression. So you gotta think the opposite. Okay, but when it is a fraction, no matter if it's an A or B, the graph gets wider. We just get wider in two different ways. So again, I'll zoom in on my picture. All right, if we start at the orange graph and get to the blue graph, if we kind of stretch this thing out in a horizontal direction, it will get wider. So it's a horizontal stretch. Okay, and again, it's the exact opposite of the A value. So when the A value is a fraction, it's a compression. When the B value is a compression, when the B value is a fraction, it's a stretch. Okay, so they are the exact opposite, you guys. Okay, so if it helps you, you can memorize the A values and just kind of reverse everything for the B values. Okay, when it's negative, it reflects over the x-axis here, but y-axis here. When it's not a fraction, it's a stretch here, but a compression here. And when it is a fraction, it's a compression vertically, but a stretch horizontally. So again, they are the exact opposites, but again, I prefer to kind of have a visual and try to visualize what's going on. But you need to do whatever works for you. All right, let's keep going. So the H value. So again, the H value, think the hips goes left to right. And to remember, you guys, the H value is also inside of your parenthesis, and it is whatever is added or subtracted to the X. But you must think the opposite with the H value. So the H value, when it goes right, you're going to subtract the H, but when it goes left, you add the H. So be careful. All right, and the K value is outside of your parenthesis. Okay, the H has to be inside the parenthesis and adds or subtracts. The K value does add and subtract, but it is outside of the parentheses. So be careful, you guys. Don't let the demon cats get you and have you mix up all these different values. Don't let them do that. Okay, so when K is positive, you do what you think it would do, you guys. Don't think the opposite with the K value. When K is positive, it goes up. When it's negative, it goes down. So again, this should all be pretty much a review. We are now just dealing with function notation, which looks slightly different. All right, let's do some example problems. Okay, so what we're going to do, I'm going to give you something in function notation, and you have to state what the transformation is from the parent to the new equation. So in the first graph, we have 1/3 times f of x. So first of all, we must know if it is an A, a B, an H, or a K value. So the 1/3 is in front of the f, which the only thing in front of the f is the A value. So it's an A value, and when A is a fraction, remember it gets wider, and when A is a fraction, remember, think back to here, when it's a fraction, okay, it gets wider, which means it's a vertical compression. So guess what, you guys? This is a vertical compression by a factor of 1/3. It will get wider, okay, or it will shrink down vertically by a factor of 1/3. So it'll be 1/3 the height vertically, which will make it get wider. Pretty cool, right? I think it's cool. All right, our next example, f of x plus 5. So first of all, this 5 is in a parenthesis, and it is added or subtracted to the x value. The only thing up here added or subtracted to the x value is the h. So this is an h value, but you have to think the opposite with the h. So since it's plus 5, remember h, think your hips that go left to right, but think the opposite. When it's plus 5, we want to say right because right is the positive direction, but it will in fact go left. So be careful. Alrighty, guys, example number 3. So example 3, f of 2x. So first of all, you guys, this 2 is inside the parenthesis. Okay, so it's either a b or an h, and it is multiplying to the x. So the only thing multiplying to the x is, you guys are so smart, the b value. You guys already knew that. Okay, and the b value is a horizontal something. Remember, the B does everything horizontal. Okay, and remember, when it's not a fraction, it gets skinnier. So if we're thinking, which way does the graph have to move to get skinnier, which I'll go back to here. Okay, to get skinnier, okay, to get skinnier, it's a horizontal compression because it moves inward. So if we look here, it's getting skinnier because it moves inward. So we are horizontally compressing. Okay, so this is a horizontal compression. So let me skip forward. Sorry, guys. This is a horizontal compression. Now, remember, everything in your parenthesis, you kind of have to do something to the opposite. Okay, the h value, you think left when you want to say right, or you think right when you want to say left. But the b value, remember, you have to flip this number or find the reciprocal. So this is 2 over 1. So when we flip 2 over 1, it will become 1 over 2. So this is a horizontal compression by a factor of 1/2. So this 2 over 1, when you flip that thing upside down, becomes 1/2. And if you think about it, you guys, if this is horizontally compressing or getting skinnier, this means it's half the size it was horizontally, which makes sense. 2 doesn't really make sense if we're getting skinnier. So it kind of makes sense to flip it. Alright, but just don't forget the b value, you do have to find the reciprocal of it, so be careful. Alright, this next one, we have something that is subtracting outside of the parenthesis, which if I look up here, the only thing that is outside of the parenthesis that is adding or subtracting, you guys are so smart, the k value. I don't even need to teach this lesson, you guys already know it. Okay, so it's a k value, and remember the k, you think kangaroo, which goes up or down, and you don't think the opposite with the k value, which means it will go down 4 spaces. Alright guys, we have one more, -1 times f of x. So first of all, this -1 is in front of the f, which the only thing in front of the f is the a value. Holy hot dog, you guys. And remember, you guys, the a value does everything in a vertical motion, so it's going to reflect in a vertical motion. So the axis that you cross when you move in a vertical motion is the x-axis. So this will reflect over the x-axis. Nice. Okay, and over here are the funsies we're going to do in class, which you guys will have to wait on. Alright guys, let's keep on going. So next what we're going to do, okay, what I've done, we're going to be stating the transformation and also solving for g of x. So g of x is going to do something to our original graph, which is f of x. Okay, and we're not only going to know what it does based on our transformations, but we're also going to solve for the equation that will force f of x to do the transformation that it says it will do. So this is f of x, so this is kind of like our parent function, you guys. Okay, and g of x will do something to f of x. So like g of x will be 1/2 times f of x, or f of x plus 7, or -1 times f of x. So we're going to know how to get from f of x to g of x based on a transformation, but then we're also going to solve for g of x, which will give us the equation that will get to the transformation, which is pretty nifty if you ask me. Okay, so go ahead and pause the video, watch example problems 6, 7, and 8, and you will discover not only how to identify the transformations, which you guys are already pros at that because that's what the last example problems were on, but you'll also learn how to solve for g of x, which actually you've kind of already done that before. In our very first unit on function, when we were using function notation, we kind of already learned how to do this. So it will be slightly a review. So go ahead and pause the video and watch example problems 6, 7, and 8. It's going to be awesome, you guys. Alright, now we are going to do something slightly different. Same concept, but we're dealing with different transformations. So if you see here, we're now moving into the parenthesis. Before, you guys, we dealt with things outside of the parenthesis. So it will be slightly different, but again, it's kind of going to incorporate what we've already talked about in function notation. So go ahead and pause the video and watch example problems 9 and 10. Alright, and these are the funsies, so you'll have to wait on those. Alright guys, our last set of transformations, example 11 and 12, or our last example problems, we're going to be combining everything we've been talking about in this section, which is pretty exciting if you ask me. Okay, so we're kind of reversing what we did over here. Before, I gave you an equation for g of x and you stated the transformation and solved. Now I've stated the transformation. What you're going to be doing is coming up with an equation for g of x, just like over here. So you're going to come up with these equations all by yourself, which is pretty exciting. And then after that, we're going to be solving for g of x. So we're going to kind of have to do one extra step compared to these problems. These problems, it gave you g of x and then you solved. Now you have to come up with g of x and solve based on transformations that are given to you, which this is going to be awesome, you guys. And we're going to be combining more than one transformation into one problem. Before, we only did one transformation at a time. So we're going to step it up a notch and combine as many transformations as possible into one example problem. So I hope you guys are up for the challenge because it's going to be pretty amazing if you ask me. So go ahead and pause the video and watch example 11 and 12. And these are the wonderful funsies that you'll have to wait to do in class. And guess what, guys? That's it.